Hey guys, my little babies. Good to see everyone. Quick work through of the morning tutoring file that I made here. Hopefully these all work out. I make these pretty quickly. This first section is very much like the first section on the quiz. Very first thing you want to do is get this missing side. So to get the missing side, we're going to do Pythagorean theorem. That'd be the square root of 180 squared plus 96 squared. You could reduce and do all that work, but since you have a calculator, there's no reason not to just go ahead and type it in. 180 squared plus 96 squared, and I get 204. So that means it was originally a triple. One way you can figure out what triple that was, in my calculator, I'm going to do 96 over 204 and see what that reduces to. And this reduces to 8 and 17. So this was an 8, 15, 17 triple. So I want the sine of angle A. I did not ask for angle A. I said, what is the sine of angle A? Real quick note, some people don't understand this, but if I say sine theta equals opposite over hypotenuse, theta is the angle, and opposite over hypotenuse is the ratio. So if I say solve for angle A, that's different than solving for sine of A. When I say what is the sine of A, I'm asking you to give me that ratio over there. So the sine of angle A would be opposite 96 divided by hypotenuse 204, which reduces to 8 over 17. That's the sine of angle A. The sine of angle B over here, the opposite side would be 180 divided by the hypotenuse 204, which reduces to 15 over 17. And then the tangent of angle A would be opposite 96 divided by adjacent 180, which is 8 over 15. So I'm just asking for the ratios there, not to solve for any angles. The next section here, let's get tricky with it. Again, I'm going pretty quick through this. This would be SOHCAHTOA. This would be opposite over adjacent. So the tangent of x equals opposite over adjacent. So x equals the inverse tangent of opposite over adjacent. I'm going to round to the nearest thousandths. Make sure you pay attention to rounding instructions on the quiz, whatever it says. But I'm going to go ahead and go to the nearest thousandths every time. So the inverse tangent, make sure you're in degrees. I was not in degrees. The inverse tangent of 12 over 10, if I round to the nearest thousandths, would be 50.194. Got it. Number 2, that's just a Pythagorean theorem. That would be 45 squared minus 20 squared. Divided by 5, that'd be 9. Divided by 5, that'd be 4. So it's not a triple, but you have a calculator. So just type it in. 45 squared minus 20 squared. And that is 5 root 65. And if they said round to the nearest thousandths, I would need to round that to 40.311. So if you know two sides of a right triangle, that's still just Pythagorean theorem. Number 3 here, I have adjacent hypotenuse. So that'd be the cosine of 9 equals adjacent over hypotenuse. If x is down low, x and the other side switch places, you know. So that'd be 10 over the cosine of 9. And that is going to be 10.125. 10.125, yes. Looking real good. Over here, got some funky numbers. That doesn't matter. That would be opposite over hypotenuse. So the sine of 41.7 equals x over 2 root 3. So if x is up high, all you got to do is multiply. So it's going to be 2 root 3 times the sine of 41.7. 2 root 3 times the sine of 41.7. Type that in. Nearest thousandths would be 2.304. Got it. So that's basic trig right there. Single triangle trig. These are level 4s here. If I have 155 degrees, 180 minus 155, I know the last corner is going to be 25. And now I need to drop a height that is usable. My favorite one is to drop a vertical height. If I can drop a vertical height, I will, and it looks like I can. Because if I drop a vertical height, this right triangle, I have enough information to work on it. So I'm going to redraw it over here and work on that right triangle. That right triangle has a 13 and a 25, and I need this side. If I take a look over on the other side, the other triangle over here, if I knew this number, couldn't I do trig to get that x that I'm looking for? The answer is yes. So I need to do trigonometry on this triangle first. That would be the sine of 25 equals x over 13. So if x is up high, all you got to do is multiply 13 sine 25. And so I know that this is 13 sine 25. Don't type that in. Don't round that. We're going to keep that the way it is. And we're going to work on this blue triangle now. And on the blue triangle, this is 55. And we know that this is 13 sine 25. And we're looking for this side, x. And I should not have called this x because there's another x in the problem already. I'm going to fix that right now because I don't like it. But I should not have called it x. I can call it anything else, but not x. X is already taking it. So I'm going to call it y, y, and y. There we go. That feels better. So over here we have the sine of 55 equals opposite, which is 13 sine 25 over adjacent, which is x. If x is down low, they switch places, you know. So that would be 13 sine 25 over the sine of 55. So I'm going to type that into my calculator, 13 sine 25 over the sine of 55, and I get 6.707. So that's the first time I should type it in right there. Don't type anything in before that. Make sure that you've got that on lockdown, my friends. Here it says find the area. We learned the area formula is 1/2 AB sine C, AB sine C. So it's going to be 1/2 times 10 times 12 times the sine of 40. If I were to clean that up, that would be 60 sine 40, but I can just type that in, 60 sine 40, and I get 38.567. Boom. So if you know that formula, that becomes a much easier question. Hopefully you can know that and do that. We got a few word problems here. It says Sam sees a tree. The angle of elevation to the top is 40. The angle of depression to the bottom is 10. So I got this person Sam here. We got a tree over here. Woo! And we have an angle of elevation to the top. So we're talking about him looking at the tree. So it's like it's coming out of his eyes in that situation. Angle of elevation to the top is 40. And the angle of elevation to the, or angle of depression to the bottom is 10. He is 11 feet from the tree. So we have two triangles. The top triangle would have 40 and 11. I'll call this x. So that would be the tangent of 40 equals x over 11. So x equals 11 tangent 40. So that's this distance. That's the distance from his eyes up. Well, then we got to work on from his eyes down. This angle of depression, we have 11 feet still, and we are 10 degrees for our angle of depression. I'm going to call this y, so the tangent of 10 equals y over 11, so y equals 11 tangent 10. Okay, so now how do we get the height of the tree? Well, if we add those two parts together, x plus y, we would have the height. So that would be 11 tan 40, the part from his eyes up, plus 11 tan 10, the section from his eye level down. 11 tan 40 plus 11 tan 10. Add those together, get 11. Ooh, this is one people will mess up. It's 11.170 if you want to get full credit. If you leave it as just 1.7, I would take off a point. So make sure you round correctly. Don't say 11.17 if you're rounding. It should be 11.170 for rounding to the nearest thousandths. The horizontal distance from Carrie to Barry is 15 feet. The horizontal distance from Barry to Larry is 20. Barry and Larry are on direct opposite sides of Carrie. Carrie is 12 feet in the air. Oh, dear. All right, let me start over again. Carrie, I know, is in the air. Barry and Larry are on opposite sides. So, we're talking about triangles, obviously, trigonometry. Come on now. So we have Carrie, Barry, and Larry.
Do I need to come at 8:05?
Yes. We have Barry, Carrie, and Larry. Make that a much clearer L. There we go. It says Carrie is 12 feet in the air. That would be a vertical distance of 12. It says the horizontal distance from Carrie to Barry. This is where students are going to really mess up. Here's Carrie, here's Barry. The horizontal distance from Carrie to Barry is 15. That is this section right here. This is not a horizontal line. If it says horizontal distance, you better put it on a horizontal line. That's my 15. The horizontal distance from Barry to Larry is 20. So if that's 15, then the other portion over here would have to be 5 because they told us the whole thing, Barry to Larry, is 20. Okay. How far is Carrie from Larry? Well, that would be this distance right there. So how far is Carrie from Larry? That's the actual distance. That's not the horizontal distance. It's not the vertical distance. If this is 12 and this is 5, that's a 12, 5, 12, 13 triangle. So 13 is the distance from Carrie to Larry. How many degrees does Carrie have to turn her head to go from looking at Barry to looking at Larry? Okay, so if she's looking at Barry and she turns her head to look at Larry, what we're basically talking about is this angle plus this angle. We need to find both those angles. So that's two separate triangles we kind of have to work on here. So we have the first triangle where we have 15 and 12, and we need that angle. We have the second triangle where we have 12 and 5. And we need this angle. So I'm going to do two different trigs. On the left side, that would be the tangent of x equals opposite 15 over adjacent. So that would be inverse tangent of 15 over 12. For the second situation, this would be the tangent of y equals opposite over adjacent. So that angle would be inverse tangent 5 over 12. And I need to add those two numbers together. So it would be inverse tangent 15 over 12 plus inverse tangent 5 over 12. And we're adding those together. Inverse tangent of 15 over 12 plus inverse tangent of 5 over 12. Total would be 73.960. Make sure you have that 0 on there. Got it. Nailed it. Okay, one more little section. Almost forgot. So this exact question's on the quiz. People mess it up all the time. I'm telling you right now what it's going to say. It's going to say round angles to the nearest degree. Nearest degree. And it's going to say round ratios to the nearest thousandths for this question. Now, what does that mean? Remember, we talked about this. This is the angle, and this is the ratio. So when I type cosine of 44 into my calculator, it says 0.7193. This is the ratio for that angle. That means on a right triangle, if you have a 44-degree angle, the adjacent divided by the hypotenuse has to equal that. That's the ratio. On the second one, they gave us the ratio and they're asking for the angle. So we're going to have to do the inverse tangent of the ratio to get the angle. Inverse tangent of 1.215, and it says round angles to the nearest degree. So that would be 51 degrees. And that is an angle. A is the angle. This is the ratio. So please, please, please make sure you read directions carefully and round very carefully on that. All right, guys, that's the work through. Hope you loved it.